Hello class. In this video, we're going to walk through the assignment project 10.3 that involved a MyInteger class and take a look at some of the requirements of this project and see how things were fit together for it so that we can review. Now, this project is one of the more complicated ones that we do throughout the class. When we look at the assignment in our text, the very end says that we need to draw the UML diagram for the class and then implement the class. We'll be writing a client program that tests all the methods in the class. Now in our MyInteger class, we're going to have one class data field named value, and this is going to store the integer value represented by this object. We'll have a constructor that creates a MyInteger object for the specified int value, a getter method, several methods that return true based on the fact that data is in a certain situation. We'll have some static methods that return true again, and some additional static methods. So as you can see, we'll be overloading these methods quite a bit, from no parameter to an integer parameter to an object parameter, so that we can see how these overloads are going to affect the processing of this program. We also had some static methods that converted an array of numeric characters to an int value, and a static method that converts a string to an int value. Now I know this character conversion was one that wasn't tested in our hypergrade implementation, so I know that in some situations that was left out of people's code, which is okay because we didn't have to really test it. So it is a requirement, however, and we always have to be careful to make sure that we meet all of the requirements of the activities. Now to begin, I'm ready to draw my UML diagram for this class, and I brought up a UML diagram from our textbook so that we could review the requirements of the UML. First of all, our class name appears at the top in the title. Then we have all of our class fields. In our case, we'll only have our one integer field named value. The minus sign here shows that these fields are private to our class and not available publicly. In our lone class here, then, we see two constructors, one default constructor for no parameters, another constructor where parameters will be passed to implement this loan. Both constructors, of course, are public, because if we don't set our constructors as public, then other classes will not be able to implement our class. Now we have some methods here. We have a couple of getters, one to get all of our different variables. Notice that all of these have a colon after the name of the method and then the return type of the data that the method returns. In this case, where we have a setter, we have a parameter instead included within the parentheses. And so we have the parameter name, colon, data type, and then outside of the parenthesis, colon, return type, which in this case is void for no return. Oh, it's okay. So we have more setters and then a couple of methods that do some processing to return a monthly payment and a total payment. So we need to try to implement our class diagram, our UML model, to look like this. So let's bring up Visio and begin creating it. I know some of you have had trouble downloading Visio. Be aware that DreamSpark has become Imagine, and if you go to the overall DreamSpark site, you will be able to log in using your OTC account, but you won't have the extended access that you have through your CIS account. So please be careful that you're going to the correct site, the Imagine site, and it should say OTC CIS department, and you should have to log on to that site. And again, please let me know if you're having any trouble that I can help you with, but it's not a critical thing for you to have Visio. You can create your UML diagrams using any facility that you like. Visio just has this template that makes it easier for you. I'm going to go ahead and choose the UML class template and create my document. In Visio, I'm going to add my class to my diagram. Zoom in a little bit. My class name was MyInteger, and our first member was our value, and we said that was an integer. Now I'm going to switch over to my example here and make sure that I'm doing things right. Looks good. We had value. It was an integer. Okay. So now the next thing that I need is a member, and I'm going to have my getter, because they said we want a method that returns value. Now because I'm going to start with my methods, I'm going to go ahead and add a separator line here, because this from now on is going to be my methods instead. I'll go ahead and create my constructors though. First, I'm going to have my integer constructor, and this one is going to be my no parameter constructor. For our MyInteger, we're going to go ahead and always assume that we're going to have an integer passed to us, and this is going to be our value. So looking at our lone constructor here, we say the name of the variable and then the data type after the colon within the parentheses. So this is going to be value, and it is an integer. And that's all for my constructor. I'll make sure here and look at that example. That should be all I need. All right. Now we only have one constructor for our MyInteger application. We are expecting an integer. Now I'm going to add another member here to our MyInteger application, and the first one, I guess, will be my getter. So I will fix this up. It's going to be public because I want to allow people to get my value, and I'm going to name it get value. Now this is going to return a value of integer. Notice it does not expect any parameters. Now that'll be my first method definition that I have. I'm going to go ahead and create my first Boolean. This again is going to be a public, and this is going to be the one to determine if it's prime. So is prime. Now this is going to be the constructor that expects no parameter, and it's going to return a Boolean. Oops, I didn't need to do that. We might be able to abbreviate that as bool, but I'll go ahead and spell it out the whole way. Now, because we want to practice overloading in this example, we're going to have another is prime that is going to expect a parameter. So I'm going to create that one here. Again, it's going to be public is prime, and this one is going to be the one that expects an integer, and we're going to call that num. This one is going to return again a Boolean. So here we have two implementations of our isPrime method. One implementation of our isPrime method is going to expect no parameters, and it's going to default to testing the value of our value variable to see if it's a prime number or not. The second isPrime implementation is going to expect a parameter to be passed, and it's going to test that parameter to determine if the number passed is prime. We're going to have one more implementation of isPrime, and this one is going to expect the object. So let's do this is prime, and instead of an integer, it's going to expect MyInteger as an object. So we're just going to experiment here a little bit and see how these different data types can be affected and how we can use the same methods and build off of our methods to create the output that we desire. So that should be all of the implementations for our isPrime method. Our isPrime with no parameter, our isPrime with an integer parameter, and our isPrime with an object parameter, and that would be an instance of our MyInteger object. So we're kind of calling our own object within itself. Now we need to create some other methods here, isEven and isOdd. And we're going to do the same thing for each of those. So let me do that real quick. First of all, isEven with no parameter is going to return a Boolean. Let me put this up down here. isEven with an integer named num is going to return a Boolean. And isEven being passed to MyInteger object will again return a Boolean. Oops, I see I left out a colon in this one. Be very careful. Okay, so I have 3 implementations of isPrime, 3 implementations of isEven for our integer class. Now we need our 3 implementations of isOdd. So you can see this thing is getting a little crazy. isOdd with no parameter returns a Boolean. isOdd with an integer parameter returns a Boolean. And lastly, isOdd with a MyInteger object returns a Boolean. Okay, so that is about finished up our class diagram here, our UML. We have our MyInteger class. It has an integer named value as a class variable, and that class variable is private. I need to put that modifier on there. It's private to our class. We're not going to let people access it directly. They can access it using our getValue method that we have supplied for them because it's public, as you can see from our plus sign. All right, so that's almost all of our methods. Let's take a look at what else we need. Oh, we need some equals methods. I'll grab a couple more members here. And we're going to have equals. And notice our method names are starting with a lowercase character. We're using camel case and uppercasing each word, but we're starting with a lowercase character. That is a Java convention. Our class name normally starts with an uppercase character, and our method names normally start with lowercase characters, as do our class variables. Now our equals method. First of all, we only have equals methods that expects parameters. Let me double check. I'm looking here. So we have an equals that expects a parameter that it's going to refer to as another num, and that will be an integer. And equals will return a Boolean. And then we'll have equals, and this time we'll be comparing to our MyInteger object and returning a Boolean. Okay, 2 more methods. Our parseInt And this parseInt is the one that's going to parse an array of numbers, and we're going to call that numbers, and it's going to be a character array. And we're going to return from this one an integer. Then we're going to have one more parseInt. Notice how our UML document is documenting what our class is going to be composed of, so that we can have that information available to share with others. Our second parseInt is going to use a string that we're going to refer to as S. And again, it's going to return an integer. Okay, that finishes up our UML diagram. It can be quite tedious, but it's very important because it conveys all of the information associated with our class to other users. So now we know that our MyInteger class has one variable named value, and the constructor expects that value to be passed as a parameter. We have all of these different methods available through the class so that class users can know what they have options for. So that would save our UML diagram. Now, let's take a look at the assignment again. So we're going to go ahead and create some of this code. I'm using Eclipse. I'll go ahead and create a new project. Exercise 10.3. I'll go ahead and add a class module here. And this one is going to be MyInteger. You know what? I think I'm going to delete that one instead, the way our book has things set up so that I don't confuse you. And let me try that again. I'm going to add a class, and I'm going to call this exercise 10_03. And then we'll be creating our class inside of there. Now, if you've been using Eclipse, you may have noticed that you can have it generate your main. I'll go ahead and do that for this one. Oh, I didn't actually do this quite right, did I? Let me pick where I want that to be placed in my folder, and that looks good. So here's my exercise, and I think I'll go ahead and put some information in here to document my program. This program is MyInteger, the developer. This program will develop an integer class and explore overloading methods. Okay, now I'm going to leave our main just kind of as it is because we'll come back to that. I'm going to come down below and create a new class. So I want to make sure that I'm after my class's closing curly bracket. I'll put a comment there. And class. Now I want to have my class, my MyInteger. Now, people have mentioned that we have to be careful about whether we have things in the same file or different files, and that's very true. Oftentimes it's recommended that each class module be in its own file, in its own Java file. If you do that with Hypergrade, you may need to be careful in the order that you upload your different Java files, but Hypergrade will take care of it for you. You also may have to include more public type statements to make sure that your class is available to a file or a class that's in a different file. Since these classes are in the same file, they will be available to each other. So my class statement can just say my class name. Now, as I create this class, try to use some curly braces here instead of parentheses. I'm going to be putting in the information that I need to create my MyInteger class. I'll go ahead and label that closing curly bracket. Some books like to do that, some don't. Now, the first thing that I have in my class is my private integer named value. Remember, he's private to my class. I'm only going to use him within the class, so I'm going to declare him right there. Now I'm going to go ahead and declare the getter for that variable. It is going to return an integer. And we're just going to return value. Now, when we're working within our class, because our variables are defined at the class level, all of the methods within our class have access to that variable. Now, items outside of our class, like our main out here, do not have access to this value because it's declared as private. But all of the methods within our class do have access. So kind of be thinking about that. That's the end of that method. Now, the next thing we are going to have is our constructor. Construct an instance of MyInteger. We do that by declaring our special type of method that's a constructor. Again, it has to be public because otherwise other classes would not be able to construct an instance of our class. Now, we said this one is going to expect an integer parameter, and it's going to refer to that integer as value within this method. Now, when someone constructs an instance, we want to make sure that the parameter they pass, the value they pass, gets placed into our class level variable so that we know what value we're working with throughout our entire class. So we're going to say, hey, for this instance of our class, this value equals the value that was passed to this method. And that's all we need to do here. We're just saying, hey, take that value that was passed and make it into our class level variable. Now, this thing could have a different name here, but the word value was placed on our UML document, so we're going to try to follow along with that documentation. But we could use any name for this variable at this point. It's this variable that matters, our class level variable. Notice how when we type this keyword, Eclipse tells us, oh, I see, this is your class level variable. It's got it highlighted in blue. We're seeing that it knows the difference. So be aware of that. Okay, there's the end of our constructor. And now we're ready to think about some of these other methods that we need to create. The first one is our isPrime. And we're going to create some different things here, so hang with me. But first, a public boolean named isPrime. And this is going to be our version that does not expect any parameter. And in this method, all we're going to do is a really sneaky thing. We're going to return a call to another method, isPrime, the one that expects an integer. And we're going to pass that the value of our class level variable value. So hang on, we'll see what we're going to do here. I'm going to go ahead and say that's the end of this method. Now, notice how even though we have an isPrime method defined, our call is calling out to us with an error saying, I don't think this is right. You don't have an isPrime method with these arguments. This type MyInteger is not applicable because we don't have it defined yet is expecting a parameter of an integer. So let's define that method and then we'll see our error go away. So we're going to do another public Boolean implementation of isPrime. This time we're going to say that isPrime expects an integer that we're going to refer to as num. Now notice how that error went away because we now see an implementation of isPrime that expects an integer parameter. It has been overridden or overloaded, sorry, and we're ready to use it. Now we need to implement the code for isPrime here. And in this module is where we're actually going to implement the code to determine if the number is prime or not. We have a loop we're going to use to back up through this number's values and see if it's prime or not. So we're going to say if the number that was passed to us equals 1, or the number that was passed to us equals 2, we know the answer for those, right? We're going to say return true. They're prime. They're too small. We don't have anything else for that. Now, after our if statement there, we're going to go into a for loop, and we're going to set up an integer named I, and we're going to start I at a value of 2, because we've already decided that anything that is under 2 or 2 is already prime. So we're going to start at that point. We're going to execute this loop while I is less than or equal to the number that was passed to us, and we're going to increment I for each iteration of our loop. Now, within our loop, we're going to try to divide. So if we can take that number and divide it evenly by I, we get no remainder. We know that we found a divisor that divides evenly into the number that was passed to us. So our number is not prime. So we can return false. I'll go ahead and put a curly brace in there. Alright, so if our number is evenly divisible by our counter variable, our I, we can return false because our number is definitely not prime. If, however, we make it through our for loop, then we do have a prime number. We didn't find any divisors for it that are less than it. That's what our for loop was doing. Got one little problem here. We need to say I in our for loop. Hang on. I equal to I less than or equal num divided by 2. And there we go. Okay, so we know if we only need to test this up to half of our number. If we can't find something that evenly divides into half of our number, we're not going to find anything that divides evenly into the other half of the number, if that makes sense. So this is a standard prime number determination module that you can use in other situations. Basically, we're saying take the number and run through all of the possible numbers that are smaller than it and see if any of them are evenly divisible. Okay, let's label some of our curly brackets. And if Okay, so now we've implemented two isPrime methods. The first one said we don't have any parameters expected, but it took our value from our class and used that value to call the isPrime method that we just implemented. Our isPrime method that we just implemented implements the logic to determine if the number is actually prime and returns a Boolean true or false depending on the outcome. Our isPrime that expects no parameters takes that true or false and returns it to its caller. So we have kind of a helper relationship going on here. Now that's two of our isPrime implementations, but we have a third, and our third isPrime implementation is going to expect our MyInteger object to be used. All right, so let's implement that one. Now we are expecting again here our object. We're going to refer to that object as O. In our isPrime implementation that allows us to pass an instance of our MyInteger object, we're going to do a lot of the same type thing. We're going to return isPrime, passing it our getValue value. So how are we doing this? We are taking our object, our MyInteger object, and we're using its name of O, and we're using that name to access the getValue method, which returns the integer of value. So we could also do it just like we did up here, but up here we're saying, oh, we're using the value of this class. Down here we're saying, oh, I could be using a different instance of the MyInteger object. So I'm going to use the getValue method of that instance of the object to see if I can get a different value than what's loaded into this instance of the MyInteger object. So getting pretty intense here. There's the end of that method. Okay, so those are all of our isPrime methods. They're pretty intense. We can start setting up our tester class here so that we can do a little testing, because we have done a lot of code for our MyInteger so far. So let's see what I can set up here. I'm going to go up to our main in our tester class, and I'm going to say that I want to create an instance of MyInteger. And I want to call that instance N1, and it's going to be a new instance of MyInteger. And I'm going to pass it the number 5. Oops, if I can get my parentheses going in the right direction. Now, notice how Eclipse understands that MyInteger is our class object. And we're going to create an instance of N1. It's mad at us because we haven't used it yet, and we're using our MyInteger class. And notice as we mouse over that the IntelliSense and Eclipse says, oh, your MyInteger class expects an integer value to be passed as a parameter. So we've all got all that information available to us because we created our class. All right, we've created an instance of our MyInteger object. I'm going to output some information here. And I'm going to say N1 is prime. Now, as I type in the name of our object instance N1, notice that we see all of the different methods that we've created that are available to us. We want to use the isPrime method that doesn't expect any parameter for this output. So I'm going to do N1.isPrime, and we're going to see what kind of output we get from there. I'd like to see a little bit more. Let's run this and see what we've got. N1 is prime. True. Okay, so we've got to fix that up a little bit, huh? I'm going to put a space there. I'm going to take N1 out and add it here. Let's run that. Look, if I just do N1, it gives me the name of this object instance. MyInteger at, and then some memory location, is prime. It's true. So let's fix this up a little bit more. I'm going to put a colon there. And now I don't want N1, I want N1.getValue, because that's going to return to me the value, which should be 5, right? Because that's the value we used to create our N1 instance of our MyInteger object. So let's run this. And I see 5 now, because I used my getValue method as appropriate. Is prime? Yes, that's true. It is a prime number, isn't it? Okay, so good. We're working so far. Our isPrime method is working. Now let's add another test here. System.out.println N1.getValue. Now we know this should be the same thing, right? But we're going to try to call this a little bit different. So this time, instead of calling our method that does not expect parameter, we're going to call our method that does expect a parameter, and we're going to pass N1.getValue in as our value, which again we know is 5, but that's not the point. The point is we're testing and we're seeing how we can run these methods and get output out and try different things. So we know that in our class, when we use this method isPrime with no parameter, it's going to use the value in our class to call this method. So again, we should see the same thing, right? 5 is prime, is true. So we can continue on and use our object, but of course we're going to get the same piece of information there. So what if I change this here and could I just put a different number? How about 10? Now we're going to get invalid results out, right? Because I am outputting one number here at the beginning of the message and testing a different number, so I better not do that. That would be kind of like the hypergrade requirements for this one, huh? All right, so we've got everything implemented. We've created a class that has an integer field named value. We've created a getter that returns that value to the caller. We've created some methods, our constructor, and then some isPrime methods that allow us to utilize the same chunk of code no matter whether we're passed no parameter, an integer parameter, or an object parameter. So the point here was to see that we could use this method and reuse our code no matter what data type was passed to us. So it gives us a lot of capabilities. Now our isPrime methods was one of the hard ones to implement. Let's look at isEven. I'm going to create a public isEven that expects no parameter, And in it, I'm going to return, let me find it, the same type thing. I'm going to return the value that I receive from another method, another isEven method that's going to expect an integer parameter. So that isEven method expects an integer that it's going to refer to as n, and it returns the following: n modulus 2 . Okay, so I had to put this comment on a lot of people's assignments. You guys did a great job. But this is all we need to do here. We have the value of n. If we can divide it evenly by 2, we are going to return the value of true. So what we have here basically is the condition of an if statement. If n modulus 2 equals 0, the double equals make it into a condition. That's going to return a true or false value. So that's all we need to do in this isEven method. Take the integer that was passed, divide it by 2, and see if it's an even number. Now it's mad at me because I've left out my return types. Okay, so everything looks good there. Happy with us. Now, putting comments in is really important. And I've just been commenting the end of our methods here because we have so many methods in this class, but we need to comment the beginning of our methods too. It's just a good standard practice. Okay, I need one more isEven method. And this is the one that's going to expect our MyInteger object and refer to it as O. So you can see how we're going to do the same thing in this one. Now, when we have our object again, we have to use our getValue method to refer to that integer value. So we're going to return isEven, the instance of O, getValue, and now we're done with our isEven methods. So notice how, again, by overloading these methods, we can use the same method whether we pass no parameter, an integer parameter, or an instance of our MyInteger object. So no matter how we approach this, we'll be able to use the same code, which again is just simply dividing by 2 to see if there's a remainder and returning that value. Now you should be able to see how easily the odd stuff is going to work. Let's do it. First of all, our no parameter is going to return an isOdd from our value, and we have to define that one. We don't like to use these small variable names, but in these little helper methods, we find it kind of easier to do. So in this one, we're going to return n modulus 2. And what do we want to do this time? Not equal to 0, right? Because if it's equal to 0, it's even. If it's not equal to 0, it's odd. And we're checking in this one if it's odd. All right. And lastly, if we use our class, our object, we're going to return isOdd using O.getValue. Now, you can see here how flexible Java is. And yes, it can be somewhat confusing, so you really need to practice your skills. Just like riding a bike, you can't do it the first time. You have to practice, and can see how we can take all this information and make it very manageable. We have 1 or 2 lines of code in each method, very easy to use, very easy to maintain. Now let's update our tester. Right now I just have the information that's checking to see if the number is prime. Well, we were also in our hypergrade example supposed to do a test to see if the number was even. So n1.getValue is even. And we'll use our isEven that expects no parameters. Got an extra parenthesis there. All right, let me clear out my console and try this. So 5 is even is false, 5 is prime is true, no matter how we try it, and it doesn't matter what we do. So we've got lots of different things that we can do here. We need to implement our equals methods so you can see what they wanted to do there. I hope you're starting to see how in this class we are just practicing overloading our methods so that we can try different parameters. Okay, our equals. With our equals, we want our user to be able to pass in another number, and that's what we're going to call it, another num. And we're going to see if that number equals the number, the value that is associated with our class. So just like we saw with checking to see if it's even or odd, we can easily accomplish this task by just comparing the value, our field level class variable, to another num that was passed to us. That's going to return that Boolean, deciding whether it's equal or not. Now, if we have an equals method where we're expecting an instance of a MyInteger class, an object instead, we're going to be able to do the same thing. Is the value equal to O's get value? Okay, I'm going to clear the console. And now we'll go up and add some of the testing for that equals stuff. Let's see what they wanted us to do here. We are going to create another instance of MyInteger, n2, and this one is going to be 15. And I'm going to say n1.getValue equals n2.getValue. then I'm going to call n1 dot equals and we're going to use the MyInteger object here, and we're going to pass n2. Alright, if I can get my semicolon on there. So let's take a look, or not. In our tester, we're creating an instance of our MyInteger as 5 called n1. Then we're creating another instance called n2 that has the value of 15. We're going to use the n1 getValue method to output the value of n1. Then the string equals. Then we're going to use the getValue method of n2 to output its value. Then we're going to output whether or not they equal each other. We're going to use n1 and its equals method, and we're going to pass it the n2 object to decide if they're equal or not. Let's run this. And I didn't put a space in there, but we see 5 equals 15 is false. So we were able to use that equals method with an object. Now our video is getting a little long here, and I included the code for you for the conversion from the string to an integer. Please use that code. Please take a look at it. In that code, you're working with the ASCII character set or the Unicode values. Please become familiar with that information, and if it's not something that is meaningful to you, and experiment with that code, because it's something that can be a problem for you if you get unexpected results because you're not thinking about char data types being the Unicode encoding. Alright, let me scroll through this thing so that you can see it all and get an idea of what's going on here. We have our main. And in our main, we just set up some different test situations. In Hypergrade, you had some various test situations to create. Sometimes it was hard to determine what was needed. In this case, I almost feel as though the tester code would have helped. So I would appreciate your input with that to help out future students. You guys have just done a great job, and I'd like to make it easier for people in the future. Now here's our MyInteger class. I'll give you a second to look at the different pieces of code. Our isEven methods. When we overload methods like this, we really give ourselves lots of capabilities. You can think about having a search option for a user, where sometimes they type in a number, sometimes they type in a string. You can handle it either way because you have methods that are giving you that capability. That's it. Please give me an email or a shout out if you have any questions. I hope this is helpful to you. I know it's a little bit long, but we do have a lot going on here in this program. Have a great